Hi, everyone. You could read the title, Unlocking SQL with Kotlin Data Analytics. Thanks ChatGPT for this title. Today we will unlock two things on the Kotlin Conf and also SQL. But probably mostly we will connect and explore the database. And please, we will have only one physical exercise for today. Please raise your hand if you never connected to the database. Never in your life. Great. For lazy people, I reformulated my question. So let me introduce to myself. First of all, I'm responsible for the stuff which I will present. I'm a project lead in Kotlin for data science, analytics, Kotlin DataFrame, Kandy, but I'm not responsible for Kotlin notebooks, honestly. Also in free time, for many years, I'm a fan of different distributed systems, including distributed databases like Apache Ignite. I was a PMC and also continue, but not so very active, committing to the different databases, data sources, and so on. Also, again, in free time, I was a TensorFlow contributor in the distributed part of that. And also, last but not least, I'm a happy father, husband. And why I mentioned this, because my son helped me a little bit to prepare the case. I will share a real world case when we try to find an IMDb database, some information about Star Wars heroes. And it looks like my memory was not so good to remember all the details. And he helped me a lot in preparation of this case. Thanks, Roman. And the first part with the motivation. It's a meme, which I prepared for myself. Again, just imagine the situation that you have some bunch of data. The Kotlin collections is not enough, for example, and you started to think that you need to switch, for example, in Excel, or probably, you know, and you could do with ChatGPT or Assistant or Copilot or something like that, the code for pandas, and you need to debug to change it. In reality, you need to switch the ecosystem just to implement the simple task with building some plots, with grouping some data which has names on the columns and so on. Or you could create your own map of strings or something like that for development. And our goal, just to help you for this routine task, not to switch every time to another ecosystem, but if you're a great Visual Basic expert with Excel, it's fine. I want to introduce just in the beginning some basic concepts, because if you're so experienced with databases, it will be very familiar to you. Just imagine that we have some objects which are hosted in the RAM. They are, for the first iteration, are pretty flat. We have columns, we have rows. Rows are numbered. Columns, for example, each column had a type and a name. And you need to somehow navigate in this table, in two-dimensional table. And this concept was borrowed from the SQL, of course, and its name a data frame. And now we have a data frame in Kotlin ecosystem too. We could manipulate by this. And the first use case is just when you have a file. It could be a flat file like CSV or Pachero if you're a big fan. And you need to convert it in some data structures, not to the Kotlin collections, but something richer. And you need to have some interesting operation on that. And we will generate for you this object. And you will obtain some functions, around 100 or probably more, to manipulate this data. And you also could export this data to the different file formats, or if you're not a big fan of this table data, you could, I don't know, build a chart, a histogram, or pie chart, or something like that. It's also available with help of the Kandy library. But we did a step forward, because in many programming languages, they have a very flat concept about data frame. But what if we could present a JSON, like a data frame too, like some substructures there, if we could generate some objects for you without any parsing, again with all available operations, not only on the first level, I mean some group by on the first level, but if you want to, I don't know, rearrange somehow some inner groups, filter them, explode them, something like that. We also generate these data frame objects for you. But of course, it's not a flat, hierarchical data frame. And again, if you want to build some chart, you could go, this is a screen from our slightly new release documentation for Kandy library. We started to think like a Kotlin developer. We don't need to go deeper in some details. We just want to pick a up a chart, just copy-paste the code and change it a little bit. It's absolutely normal. And if you will click on the different examples, you will see that we provide two options for copy-pasting if you're working with DataFrame or if you're not familiar with this concept or you want to ignore or build some charts for your loved data collections. So it's also possible. Okay, you could ask me, what about databases? Where are the databases? We are on the 8th minute of my talk. So, from my previous life experience with databases, if you're not starting from the console, you're starting from something from your loved vendor, like this or something open source on the internet, and you need to make a connection to explore their structure, to understand some restrictions, some constraints, some cascade deletions, or something like that. But we try to collect the main issues for backend developers, not only Kotlin, I think the same for Java developers or for Android developers, and they have deal directly with SQLite, not through the different layers of abstractions. First of all, it's fragmented reporting tools for each SQL database, especially if your organization have deal with different SQL databases. You need to learn more here, and you need, in many cases, abandon your loved idea just to explore something, or sometimes you need to deliver this work to the analysts. Also, you need to, from time to time, if you record somehow your activity, switching between IDE, not only IDEA intelligence, but other IDE if you prefer, and database tooling. Also, if you're trying to write the common code for a few SQL databases, you also face it with different SQL dialects, first of all, and probably you sometimes faced with different ideas how to implement JDBC protocol on the server side. It's really interesting, especially for some type mapping. For example, there are a lot of different known bags for many years, for PostgreSQL, not only. And also, if you need to merge some multiple sources, if you have not only SQL, or just imagine you have a task to merge two tables from two different SQL databases, you need to do this. Some people do this in this area, they denormalize data, put this into NoSQL or something like that, or different storages, but we provide this ability also. You could do this on the DataFrame side. Of course, please don't count the performance in this case, but it's also available. And also, last but not least, we face it every time with, just imagine you work in some workbench or something like that, and you need to share the results. You need to take this collected data and became a part of your code. It's also difficult. You need to copy-paste, export to CSV, and download again, and parse it again, and so on. And also, it's very limited in presentation. When you did something on your site, you, for example, need to share or present your colleagues somehow the result of your investigation, your proposal. And again, we put a lot of effort to prepare the tooling for effective presentation of data of your exploration, of, for example, of your databases also. And our solution, I just summarized very, very quickly. Our proposal here, we suggest to use Kotlin notebooks and DataFrame library together. We believe that it's also possible when you need to explore the structure of database, when you need to explore when you need to make a very fast MVP for some prototyping of some SQL queries, when you don't need to pay a lot of attention to the performance for the first analysis, it's also fine to work in this environment. And we also propose a standardized API for manipulation of this data for all available on our site SQL databases. And we're also working on easy sharing the results. If you, for example, if you're doing something on the open source data set or open source database, you could easily share via GitHub GIS, for example. I will demonstrate a little bit later. Or you could just send your colleague, your friend, the notebook, and he could run this notebook or not run if it was something private in the private repository, and see the results in the order and with your comments without any repeating deals. I mean, so supporting from the previous year some databases. We started from a few widely used and which have not so many problems with implementation in JDBC protocol. It's PostgreSQL, it's MariaDB, it's MySQL. MariaDB and MySQL also have some difference here. It's also work for SQLite. If you're working with this, I believe most of you worked somewhere with SQLite. And we are working on adding new SQL databases. For example, now in the master we have a support for MS SQL. We will have more. And again, in the future, like for many database tooling, it will be available an option to register your own SQL source or SQL dialect with implementation of some classes. This API for registration is not available yet. When it will be available, when we collect some user requests, please join. If you have your own SQL data source on your hat, please create a request and let's collaborate. And when you parse some data, you should not worry that you write something wrong in your database. We provide for now a function only for reading. But again, we have a user request on our GitHub issue. Please just convert the data frame to the table on the SQL database. It's also an issue about different mapping of types, and it will be implemented this year also. So today, I will present some teeny demos around the EMDB database. Probably somewhere in your developer life or probably everyday life, you face it with this data source or this database. It's pretty known. And what we have there, we have a few SQL tables, some information about actors, their roles in different movies, movie directors, and genres of different films. And I will not cover all these tables in my examples, but we'll try to demonstrate this in the demo. So let's switch to the demo. I hope you could see the numbers and symbols right. And I want just to start the demonstration from the simple case. Just imagine that you not have a SQL database yet. You just have a CSV file, or, for example, JSON file about different movies. And in the first file, it's just a subsample of the movie's SQL table. And the second case, it's a result of grouping by the year of these movies with the ranks and year when it was produced. What I could do with this file, I want to demonstrate this feature because I really love this. If you drag and drop the file, some snippet of code will be generated, and it will be generated not only snippet of code, the schema also will be generated under the hood, and we will display the data frame in this data frame view. And probably yesterday we released a nice article on the Kotlin blog where you could read more about these data frame views. Please go to the Kotlin blog and read our article. We put a lot of effort to prepare some nice mini demos and GIFs for you. And also, if you want to handle a JSON, this JSON is too big, it's around 25 megabytes. I could open another notebook and also drag and drop your JSON. I believe that in future we'll support the same for the SQL sources, but for now it's only for the files. We also could see the hierarchical data frame. We have here two columns, year and group, and if I click, for example, on this group, I will see the group it by year, name, year, and rank, and I could return, and I could somehow go through all this stuff and sort if I need the year. So this is a very teeny demonstration of what we have in the Kotlin notebooks, and we will start from the beginning with EMDB database, SQL database. I will try to teach you a little bit about the API today, and I hope it will help you to start if you have your own SQL database. So, EMDB database, you saw the structure. First of all, you need to start from the dependency on the JDBC driver, which you need. It's emulation of class for name, if you're familiar with that. You also, if you need to import our libraries like DataFrame and Kandy, and they have a support for completion for them, for quick documentation, so on, you also need to use this cell. What we will do in the first demo, we just take a actor table, we will read the data, transform a little bit. It will be really teeny transformation, very SQL-like, and we will build a plot with a Kandy library here. And I'm not sure that it's pretty quick, pretty large, the schema, but if you remember the actors here in this site, we have 4 columns here: first name, last name, gender, and ID. And I need, of course, set up to the connection to my database. In this case, it's MariaDB, hosted locally on my site. And now it was set up. And I need to, in this first case, just read first 10,000 rows from this table. Let's run the cell. It will display it because we call the actor data frame, which was created here in this row. And here, what I want to do, I just want to group by somehow data. It looks very familiar, which you have. And here we have some properties which were generated under the hood. We also have access to the last name, for example. And in the previous case, we did this on the first name, no big deal. We could go to the group, see that group is not so big because last name is not so unique. Let's return to the first name. And let's again run the cell. What we have here, okay, groups much more bigger. For example, Mikhail repeated 45 times here. We could see that how many Mikhails have we here. And what I want to continue, I want, for example, to count a number of rows in each group. I just need to call a function count on the result. Okay, the new data frame was generated here, and also these 2 properties with first name and count also available after running this cell. And this is a full code of our data manipulation here. Again, if you're familiar with SQL, it looks pretty familiar because it's only simple top of the iceberg, the function which we provide. If you have a SQL query, you could easily map this on the data frame concept, but we have functions which you don't have on the SQL side, especially on all the SQL databases. Here, I want to sort a little bit and take the top 20 of the main actor names, and I want to build a chart. I could call a function with name a plot, which is available on the data frame. And in this case, I want just simple bars. Then on one axis, we have our first name and the count number on the y-axis. So let's run. And we will see just simple plotting. It was the first example where we just read the data, group the data, and build a plot. So in the second, we will continue this the same database. Again, probably here we need some imports. Let's pass here. And it will be kind of investigation. I will try to tell you a story of our exploration when we're trying to find one actor from the Star Wars. I believe that you're a little bit familiar, probably not with first 3 episodes from the 17th, but I'll try to find an actor because my son every time asks me, oh, do you remember the name of this actor? Do you remember the name of this character? Do you remember how he's playing in another film? Sorry, I don't remember. My memory is full with Kotlin, not with Star Wars heroes, sorry. And we're trying to find more information, to extract more information from the movies table. And sorry, I need to run this markdown to be read much more better. And again, I'm trying to find one hidden JD, probably from the light side of the moon, and I need to read the whole data from the movies table. There were a lot of, around 400,000 rows here, and I want to filter from this database all the films or movies which contain something like Star Wars in the name. I'm calling on the properties the function because it has a string type, and all these functions are available, and I found around 63 rows regarding this, and I'm trying to go through this. My son suggested me search among heroes from the probably some deals with clones. I don't remember exactly. Was it the second episode or the third episode? Okay, I will go from that, and we found that probably it was attacks of clones. Okay, it has a rating, because this movie's SQL table has some unclear data, the films, duplicates, films without rating. It's MDB database, it's fine. And we will try to keep the IDE to connect with another table. And let's observe all roles in the second episode. And we will download the another table from roles, and let's filter among all the roles only, because we have only actor ID, movie ID, and role, but we have no actor name here. Let's do this. And we found that we have around 70 roles. Okay, we go together, and we see that, no, probably the good JD was not R2D2. No, it was not Jar Jar Binks, probably. And we continue. Okay. Okay, it was a maze window, said my son. Okay, let's continue. Let's try to recognize what actor played the maze window. He looks so familiar for me, but I really don't remember the names. I could not keep this in mind. And we again copy his ID, actor ID, and let's go through the actor table. And again, I just remind you who is Mace Window, if you remember. If you don't remember who that. But I forgot the name of the actor. And we go through this table and try to filter with this ID. Okay, Samuel L. Jackson? Okay, he's popular a little bit. Let's try to find his roles in the roles table which was loaded before. And we see that he played a lot of roles, especially of himself, in different episodes, movies. And let's try to find, is he ranked high or low? Is it very popular actor, or he played in bad movies with very bad rating? And we need to make here a join. The most difficult part in the SQL. If you're not familiar with that, on the SQL side, you could do this on the data frame. And what we need to do this, we need to match somehow movies, all the movies on the Jackson roles, and we need to match two IDs from one table to another, and just select only year and rank. I think it's enough for Jackson movies. Let's see. Oh, I also had a very nice picture of his famous roles, if you don't remember yet who is this actor. And yeah, he has a lot of different roles starting from the previous century. And let's build a plot, the average rating of films in which he participated. And it will be much more difficult, bar and plots, plotting, because we also want to build an average rating on that. And what we have here, we will try to build a colored area. And also, we want to add in this very nice DSL in Kandy, we want to add a line which will display the average rating across all his movies. Let's build. And we could see that he started not from very popular film, but in reality, before the end of the data in my SQL database, which ended 20 years ago. Sorry for that, but the open data could be started a little bit. We could see that his average rating is pretty high, and he had a lot of films which had a rating which is much more higher, and probably you know part of them, but also have some troubled films. To summarize a little bit, if you experienced SQL developer, of course you noticed that some of my operations were not effective from the SQL side of view. Of course, I could do the join on the SQL side. It's important to understand. But if you're not familiar with SQL, I don't know, ChatGPT could not generate an effective SQL for you. You could do all the stuff on the data frame, but of course, all the data will be loaded to the RAM, and you will join this on the heap side. It's required to remember. And if you have a SQL query which you prepared on your site, or I don't know, from your previous past experience, which you need to run, we also support, of course, API for that. We loading not from only SQL table, but also from the result of SQL queries, and also generates data frame for the result. And I will show you the latest example. We will explore a little bit the genre popularity across the years, and what we will do here, again, I need to establish the connection here. And I want to compare, in this example, the popularity of comedy and horror genres across the 20th century. And I believe that we could compare a little bit the audience perception of all these genres, or probably we could decide that people produced in the middle of the previous century very bad films. It depends. To prevent overloading RAM, I prepared an SQL query. It will be performed on the SQL side. And what we will do here, I want to extract name, year, rank, and genre from result of inner join of two tables of movies and movies genres, because it's two separate tables. And I want to filter a little bit, make a push down predicate optimization, and filter out the movies without the rank, a lot of them, and of course filter the films which are not related to these two genres. I just need to insert the SQL query to our read-SQL query method. And again, the data frame will be generated. We have only 23,000 rows instead of 500,000. And we will do some aggregation here. We have a few APIs, probably one, could you remind it, an SQL. If you're familiar with MongoDB, we have something like aggregation framework. We have a common function aggregate as an alternative. I will stay with this row, but I prefer more SQL-like way for grouping the data. I select 3 columns, group by year, genre, and I want to calculate the mean across all the data. And let's visualize this. What's happened? We have the year, genre, and mean rank across the years for each of those genres. And we just built the 2 plots, and we could see that between 2 world wars, we have a highly ranked and horrors and genres. But we could see that horrors which were produced later were estimated badly, so from the audience. If you want to export this plot, not only this, but if you have something in the notebook, we have 2 ways here. You could directly call the function with name save and export in your preferred format, but you also, which will be saved, but we also have an option here, not only copy text, but save plot as and save in your preferred format, in the directory which you need, and change the schema, and so on and so on. You could handle it in both ways, depends on what you need to do. So that's all for the demo. Give me a few minutes to return to my presentation and talk a little bit more about some stuff. I just want to show you, we have a very nice documentation about data frame library. We have 3 main entry points for Kotlin for data analytics. From the previous month, we have our own pages on the Kotlin side documentation. You could go there and open the Kotlin for data analysis subchapter and go through the tutorials which are provided there. All examples also provided. Or if you need to learn more about specific operations, specific use cases, you could go to the separate documentation of the data frame, of the Kandy library, and especially if you're interested in reading something from SQL databases, you could find here, of course, we have a very hierarchical structure. You could search from here, or you need to go to the input-output to read from SQL databases. This is experimental model we've named DataFrame JDBC. And if you need to enable this, you need this dependency. It's described here, how to start with all the databases, which dependencies you need, some description of the methods. We have more methods. If you're, I don't know, big lover of ResultSet, we also have some method on that. And you could go and download the official example, which is hosted by my personal account for now, but will be moved, I believe, in the Kotlin organization. Kotlin DataFrame SQL example, it's official example with this MDB database with a little bit different notebooks and slides. I'm not repeat myself every time during the presentation. And you could start with that, but you need the installation of SQL database, of course. In our situation, it's MariaDB. I provided an SQL dump for downloading. If you want to start with other SQL database, you could start. If you will find some very funny open-sourced SQL database, please share with us. We probably will include in our official examples also. Returning to some stuff, I also included to the presentation, which will be available, all the possible links. Oh, give me a second, I need to demonstrate also Kandy. I really love this. We have here a lot of different examples. For example, a slightly new candlestick. If you're, I don't know, big lover of financial stocks, analyzing Bitcoin, something like that, you could start with that. We also published an article how to analyze financial data and build some charts. Or if you're fan of histograms, you could just go to build this histogram, just copy-paste for data frame, for collections, and continue in notebooks. Yes. We have, for now, limitation. We are first-class citizens in the Kotlin notebooks, but all the stuff with data frame, with manipulation, is also available for Gradle project. We also support the generation of schemas in Gradle, but you need to put more effort to perform this. We provide all the instruction. If you're interested, we also could generate schemas for SQL data sources, for files, for something on web, and so on and so on. But it's not so easy to start like with Kotlin notebooks. It's mostly all which I wanted to say. We have a time for questions now, and thank you. Don't forget to vote. Thank you.